Alright, in this video we're going to focus on a very specific type of function, and I'm sure that you've seen it before, so this shouldn't be too scary, but we're going to focus on what are called linear functions. And linear functions look like this is one way you can write a linear function. It'll always be y equals, or function is equal to the expression a number times x plus a second number, which we traditionally call b. Alright, and we want to talk about the slope of this function of the graph. We want to talk about the inverse. We want to talk about different forms that you can express the function in, and parallel perpendicular lines and intersecting lines. Okay, so if we have a function, like for example, an example of a linear function would be 3x plus 1. Okay, the number in front of the number in front of the x, this is the m value, that's also called the slope. That will affect how steep the graph is. So if you were to graph this function, what will happen is you start on the y-axis at the b value, in this case 1. Okay, so you start at y equal to 1, and because the slope is 3, what that means is you want to go up 3 every time you go over 1. So up 3 over 1, and that will get you there. And so then you can draw a line between those 2 points, and so that is the graph you are looking for. Okay, so and if let's do another example. Let's say that we had let's make that graph black. Let's say we had g of x was equal to minus 2x minus 1. Alright, so what's going to go on with that one? So now we're going to start at y equal to minus 1. Okay, and the minus 2 tells us that we're going to go down 2 every time we go over 1. Okay, so if you did that, you go down 2 and over 1, that would get you here. So let's now draw a line between those 2 points, and there you go. Let's change the color. Let's make it how about green? Okay, so the black line is f of x, the plot of f of x, and the green line is the plot of g of x. And you saw how the coefficients, the m and the b, affected the location and the steepness of the plot. Alright, I graphed it. Okay, by the way, where graphs cross the x and y axis, those are referred to as the intercepts. You have x-intercepts and y-intercepts. Okay, the y-intercept of the black line is 1, y equal 1. The y-intercept of the green line is y equals minus 1. Okay, and then the x-intercept is wherever it crosses the horizontal line. All right, let's say I had this other, let me just draw a graph that has where it's easy to see what the intercepts are. So this orange line, okay, so the x-intercept of the orange line is 1, the y-intercept is approximately minus 2. I'll put a red dot on the intercept that I'm talking about. So the x-intercept, x equals 1, the y-intercept, y equal minus 2. Okay, now what about vertical and horizontal lines? Okay, so let's do a horizontal line y equal to 3. Okay, so so the way that you would write the function, let's not call it f of x, we already used that. let's say, let me do it here on the bottom. Let's say h of x is equal to 3. So that means that the height is always 3. So it's going to be the purple line, the horizontal line with always has y equal to 3. Okay, and then we can't really have a function that's a vertical line, okay, because it fails the vertical line test. Okay, so what we do we can still draw a vertical line, but we understand that it won't be a function. Okay, we express it as that vertical line has the x value is always 3 on that vertical line, so we refer to it as x equal to 3. But again, let me repeat, that's the only one that's not a function. Okay, now if you wanted to know where lines intersect, okay, like for example, you might notice that the black and the purple lines, the light purple and the black lines intersect. So in other words, the f and the h, f of x and h of x, those two functions intersect. Let me put a dot where they intersect. I'll make it a green dot. All right. So what if we wanted to know, what if we wanted to know the coordinates of that green dot? It looks like it might be about 1, 3, maybe a little bit less than, maybe 0.9, 3, whatever. So what you do in order to figure that out is, well, we have to see where do they both have the same x and y, or what point is on both graphs that has the same y value for the same x value. So in this example, the h is always 3. So let's ask ourselves, when is the f of x function, the 3x plus 1, when does that equal 3? Whoops, hold on. So 3x plus 1, set it equal to 3, and let's solve for x. So 3x equals 3 minus 1, so x is equal to 2/3. Okay, so the intersection is 2/3, 3. Okay. Now, you will often have different functions whose graphs are parallel. Okay, let's talk about that. If I had f of x equals 3x plus 1. If I had, well, let me go to a new board, and you'll see what I'm talking about. Maybe I was getting a little messy. So I'll draw multiple graphs, and you'll see the pattern, I'm sure. Okay, so one of these is the graph y equal x. This one is the graph y equal x plus 1. The next one is y equals x plus 2. The other one is y equals x minus 1. Okay, now notice that they all have a slope of 1. Okay, so that's the first observation. Parallel lines all have the same slope. Okay, now what changes? Well, the height, the location of the line changes, so really the y-intercept changes, so it's the b value. Okay, did you guys get that? So so y equals mx plus b. The m will be the same, but the b values is what's going to change for parallel lines. Okay, and then lastly, let's talk about perpendicular lines. So if a line is perpendicular, okay, I'll show you. You can I'll show you the formula to calculate the perpendicular line, and you tell me if you can tell if it indeed agrees with it. Okay, so if I had a perpendicular line like that red one, okay, what has to be true of the perpendicular line is that the slope is the negative reciprocal. Okay, I'll write it and then I'll show you what I mean. Perpendicular lines have slopes that are negative reciprocals of each other. Okay, so I take the slope of the orange line, m equal to 1, and so the slope of the perpendicular line, by the way, the symbol for perpendicular is an upside down t. So what I do is I invert it, 1 divided by the slope, and then I put a negative. So -1 is the slope of the red line. Okay? If I had a graph that had a slope of 2, okay? So let's draw that. Let's put a 1 here, x equal to 1, and here's x, y, 2x. Okay, so that purple line is y equal to 2x. So for that one, we have m equal to 2, and the negative inverse is going to be -1/2.